In this video we're going to do an example of the Bresenham's algorithm. So we want to be able to draw the line that starts at position 1.5, 0.5 and ends at position 8.5, 3.5. Now if the Bresenham's algorithm works out correctly, it should choose these blocks. So by choosing the block, what I mean is it will go to the center position here of each of the blocks. So it's going to start off at this position here, which is the 1.5, 0.5. So this block is chosen automatically. Now the next block here, the largest part of the line is within this block. So we should be choosing the bottom block here. So we've got a choice between these two and we choose the bottom. And it's going to be the value of 2.5, 0.5. So that should be our next value. And then the value after that should be 3.5. And this block here is going to be centered at 1.5 and so on and so forth. So we'll go ahead and we'll go through the Bresenham's algorithm for the first couple of values here in the next slide. So you can see here we've got our initial position, which is x0, y0, which is 1.5, 0.5, and the final position for the line is x1, y1, which is 8.5, 3.5. So the first thing we do is we'll work out our delta x. So our delta x is going to be x1 minus x0. So that's going to be 8.5 minus 1.5, which gives us the value of 7. The delta y is going to be y1 minus y0, which is 3.5 minus the 0.5, and that gives us the value of 3. Now we need to find out our initial value for our pk. Now I've written the algorithm down below here just as a reminder. So the very first value for our pk is going to be 2 delta y minus delta x. So when we come up here, we're going to have the p1 is 2 delta y minus delta x. So it's going to be 2 times delta y, which is 3, minus delta x, and delta x is the value of 7. So it's going to be 2 times 3 is 6, minus 7, which is minus 1. So now we're in a position to now look at finding our next box. So we know that the value for our pk is less than 0, it's minus 1. So if it's less than 0, we use this little part of the algorithm here. So the next value, xk plus 1, is always the same. It's the value of xk plus 1. And the value of yk remains the same. So yk plus 1 is the same as yk. So this is going to give us our first point. We're going to have xk plus 1 is equal to, well, the original value for xk is going to be 1.5, and we add 1 on, so we go to 2.5. There's nothing surprising in that, we just go to the next x box. And the y box remains the same, so yk plus 1 equals yk. So it just remains the same at 0.5. So we have our next position here is 2.5, 0.5, and you can see that that is indeed correct. If we have a look in here, you can see that we're going to have the position 2.5, 0.5. So this box has been chosen. So the first one is correct. Now, in order to move on to the next one, we need the next value of pk. So in this instance here, whenever it is the less than 0, we work out our pk plus 1 is equal to pk plus 2 delta y. So we have that up here. We're going to have pk plus 1 is pk plus 2 delta y. So that's going to be the last value of pk, which is minus 1, plus the 2 times delta y is 2 times 3, which is -1, plus 6, which is 5. So we've got our new value for pk. Now the new value is now greater than 0. So we go through the algorithm again, but in this instance the value for pk is greater than 0, so we use this part of the algorithm. So we can see here that the value for our x of k plus 1 is x of k, and we add 1 on, so we just go to the next box. But in this instance here, y of k plus 1 is y of k, and we add 1 on, so we choose the box above. Okay, so we're going to have the x of k will then go into the point 3.5, but y of k will go from the previous y of k, which is 0.5, and we add 1 onto it, so it goes up to 1.5. So we end up with a value 3.5, 1.5 for the second point. And we can see if we look in here that this point here is indeed 3.5 and up 1.5. So we choose this box here. So the best way to proceed with the rest of the values is to draw out a little table. So in this table we're going to have the initial value for our decision, which is pk, and then we're going to have the pk plus 1, and then we're going to have the value for our x, so that will be xk plus 1, and the value for our y, so that's yk plus 1. Now in the previous page there we worked through a couple of examples. So we started off with the original point, which is 1.5, 0.5. We then worked out the value of our pk. So the initial value for our pk is -1. From this we can then work out xk plus 1, so it's just simply the xk and we add 1 onto it to get to the next x position, and the yk plus 1 remains the same, 0.5. So that gave us our next point, and we were able to work out the pk plus 1. Pk plus 1 gave us a value of 5. So we can take this value of 5 down, which becomes our new pk value. Now from this pk value we can work out the value of our xk plus 1. So our xk plus 1 is again just going to be the 3.5. Now because pk is greater than 0, the yk plus 1 becomes 1.5. So these are our next points. So from that we were able then to work out the next value, pk plus 1, which gives a value of -3. So I'll go ahead and populate the rest of this table just now, and then you can work through each of the lines yourself using the algorithm to generate the actual values. So let me do that now. So I've gone ahead and worked out the rest of the values, and I suggest that you work through these by yourself. If you have any problems, then you can always get in contact. Now what we want to do is check the actual points and see whether they match up with the points that we expect to get from our line. So we know we've got the 1.5, 0.5, which is this point here. We know the 2.5, 0.5, which is this one, and the 3.5, 1.5, which is this one here. So the next one's going to be 4.5, 1.5, so that's this point, 4.5, 1.5, so it chooses this one. The next one's 5.5, 2.5, so we come along here and up to here, and it chooses this one. And then 6.5, 2.5, which is this one here, and then 7.5, 3.5, and finally we've got our last point, which is our 8.5, 3.5. So the algorithm does work, and it does produce all of the points we are expecting. So what we want to do in the next video is go through the extension of the algorithm so that it will work in all other quadrants. So thank you for listening. I'll get you on the next video. Goodbye.